So a few people were away when this lesson was taught, so I thought it might be a good idea to record the solution for this worksheet. This is class worksheet 5 limiting and access, question 1. Now question 1 is actually a revision of gravimetric analysis. So I'm just going to go through the question again. Many garden fertilizer contains sulfate ions. The first thing that you always want to pay attention to when you do this kind of question is, what is the ion under investigation? So we're interested in sulfate ion. The formula for sulfate ion is SO4 2-. Gravimetric analysis can be used to determine the soluble sulfate content as follows. So gravimetric analysis is just a way to determine amount using via precipitation or via mass, really. But most of the time the mass is achieved via precipitation. I think I need to get rid of this cursor. Okay. So the way that the experiment is conducted is you start with 2.5 grams of the sample and you dissolve it in water. So we have 2.5 gram. Now this is completely, I'll draw it down here. 2.5 gram of barium sulfate. Sorry, of sample. So this is not the mass of barium sulfate. It was dissolved. So this was dissolved in water. And then you add barium sulfate. You add barium chloride, which is the precipitating reagent. And as you add barium chloride, this is going to form barium sulfate precipitate at the bottom. So we have BaSO4 solid, and the mass of barium sulfate is measured to be 0. Okay, the lines are not a good idea here. 0.566 gram. The question, calculate the percentage of sulfate ion in the fertilizer. If you want to determine percentage of sulfate ion, essentially this is percentage by mass of sulfate ion in the fertilizer. So it's going to be mass of sulfate ion over mass of sample times 100. That is ultimately what you need to calculate. We already have the mass of the sample, which is 2.5 grams. So what we need to do is to use the mass of the precipitate to determine the mass of sulfate ions. So the first thing I'm going to do is I'm going to determine the number of mole of barium sulfate from the mass. You need a, okay, you don't really need this, but let's start with this M and big M. So we need N of BaSO4, which is going to be mass divided by molar mass. So the mass of barium sulfate is 0.566 grams. And to get the molar mass of barium sulfate, you need a periodic table. Barium is here. So barium is 137.3. 137.3, sulfur is 32.1, and 4 times 16. So 233.4 is what I got for the molar mass of barium sulfate. 233.4. So the number of mole, 0.566 divided by this is 0.0. So 0.0024. Let's go with 3 mole. So this is the number of mole of barium sulfate. Now from here, I'm going to use mole ratio because ultimately I want to find the mass of sulfate ion. So I'm going to try to find the number of mole of sulfate ion from the number of mole of barium sulfate. I'm just rewriting the equation that is provided to you. But barium plus sulfate equal to barium sulfate. So if you look at the coefficient of everything, it's a 1:1 ratio. So N of SO4, 2-, is going to be the same as the number of mole of barium sulfate, which is also 0.00243 mole. Okay, now once I have the number of mole of sulfate ion, I can find mass of sulfate ion, which is number of mole times molar mass. So this molar mass is not the molar mass of barium sulfate, so you need to just get SO4, which I think it's like 96. Yes, 96.1 if you use 32.1 to be the molar mass of sulfur. So 96.1. So use the calculations from your calculator. Keep the exact values. It's not that. 233 grams, and we don't have enough room, so let's just make some more. Step 4. The percentage mass by mass is going to be 0.233, which is the mass of sulfate ion. Wow, that went well. 0.233 over 2.5, which is the mass of the sample, times 100. Which is 9 point, so if you correct the two significant figure will be 9.3%. So that's the final answer. So that's a quick revision of gravimetric analysis, question 1 of this worksheet.